So I'm interested also in this idea of hydration, and you mentioned that the fascia can get so stuck that like literally the hydration, the water can't get in there, or it's not being.
Yeah,
how does it work?
Couple different components here. I think everybody knows, right? Like water is super important. We're made of, 55 to 70% water, and if you don't drink enough of it or you're not hydrated, you can die. But we don't. Even I didn't know until just recently how this actually happens internally, because it's not enough to just drink water. You have to get the water into your cells. And the cells actually pull in water from the extracellular matrix. So every cell in the body, they're intracellular and extracellular. So we don't need to get super sciencey, but the cells want to pull that water out of the extracellular matrix, or ECM. The ECM is part of the fascial system.
Okay.
And the ECM is composed of a lot of water, like 70%. The rest of it contains like the glycoproteins and collagen that your body also needs to repair. So if you have a tendon injury, for example, you're going to need collagen to repair it. If you have a different type of injury, you're going to need something else, maybe that hyaluronic acid that imbibes water in that fascial system. So you need a water-rich ECM, or fascial system, in order for your cells to pull it from there into the cell. And so if your fascial system has lost its hydration, it's kind of like if you imagine a bunch of dams on a river. The water's not going to flow.
Okay.
It might be stuck up here wanting to rush down, but you've got all these dams. So that fascial restriction, where it starts to get dehydrated and then stick to itself, and it starts to cause a dam. And then the water's not flowing.
So even if you're drinking plenty of water, if you have these adhesions, it can't get in. It doesn't matter how much water you're going to drink, it's still not getting in because of the
You're
adhesions.
going to pee it out. Yep.
Very interesting.